All right, today we're talking about assignment 8.1, what is normal? So when we have data sets, we put them into these histograms, and then we like to look at the shape of the data set, and that can kind of tell us about trends in the data. So we want to focus in on what we call a normal distribution, and your job is to figure out what it is that makes something a normal distribution. So here on problem 1, we have this picture right here that's a normal distribution, and we have this picture right here that is not a normal distribution. So your job is to look at these two pictures and tell me, what differences do you notice? Well, hopefully if you looked at this normal distribution, you notice that it's symmetric. Can you see how it's the same on one side as it is on the other? So one thing I notice here is that it is symmetric. I also notice if you zoom in, we have this letter that kind of looks like a U. It says that that equals 0 and that this thing is equal to 1. Now, if you looked at the notes page that I posted with this assignment, you may have noticed that this symbol right here is what we call mu. It's a letter of the Greek alphabet, and it's the symbol we use for the mean or the average. So we're saying that the mean or the average is 0, which you notice is right here where I drew in this purple line. And then this second letter is what we call sigma, and that is a letter of the Greek alphabet. And we use that letter for standard deviation. And standard deviation is a measure of spread. So this is saying that we are spread out by, in this case, 1. So for example, here's 1. There's our first little measure of spread. Here's 2, our second measure of spread, our standard deviation. And you notice how on the other side, we kind of mirror that. So we know for sure it's symmetric. As opposed to if you look at this one right here that's not a normal distribution, can you see how we kind of have a tail right here on the left-hand side of this picture? So because it has that tail, we would actually say that this data is skewed. And we would say it's skewed to the left because the left-hand side is the side that has the tail on it. So one important thing that we want to notice about a normal distribution is that it is symmetric, not skewed. If you look at problem 2, again, here in our normal distribution, notice how the mean, the median, and the mode all land smack dab in the middle of this symmetric normal distribution. Again, notice that it's symmetric, but we also have the mean, median, and mode are all smack dab in the middle. As opposed to in the one that's not normally distributed, I'm going to see if I can get this to zoom in. There we go. Okay, notice how we have the mode here, median here, and the mean right here. They're not the same. They may be a little bit close to each other, but they're not in the same place. And notice also how, once again, we have this tail right here that tells us our data is skewed. And in this case, because the tail's on the right-hand side, we would say that it is skewed right. Okay? Well, number 3, again, I notice that I have this same nice symmetric curve, and this time I told you the name of this curve. We call this a bell curve because it kind of looks like a bell. So in a normal distribution, we have a bell curve. As opposed to our not normal distribution, which again, notice how we have that skew, and this time, since the tail's on the left, we are skewed to the left. Okay, well in our next picture here on problem 4, again we have this nice lovely bell shape that's symmetric, and we have these little inflection points that are 1 standard deviation away from the mean. So that's one thing we notice. I'm just going to list here again that it's symmetric. As opposed to if we look at our non-normal distribution, notice how we have here these two kind of little humps. So each of these little camel humps represents a mode. So we would say that this particular distribution is bimodal, meaning it has two modes because it has these two camel humps. Okay, problem 5. Again, I notice that I have this nice symmetric bell curve in my normal distribution, as opposed to in the one that's not normally distributed. This time, notice we have these 3 camel humps. So we could say it's trimodal, or we might also say it's multimodal, meaning it has more than one mode. Definitely not normal. So here, once again, I notice that I have my bell-shaped curve that is symmetric. And it is not multimodal. Okay. Here on picture 6, notice how once again we have this nice lovely bell curve shape, and this middle line right here represents the median, or the middle of the data, and notice how the way it falls once again is symmetric. We have a nice rising curve on the one side and a nice falling curve on the other. So once again it is a symmetric bell curve shape. As opposed to our non-example here, once again has a tail. Remember, we call that skewed. And in this case, because the tail is on the right-hand side, I would say that it is skewed right. Okay, and then our last example, once again we have this nice bell curve, but this one is actually kind of interesting because it gives us these percentages. And these percentages apply in every single normally distributed distribution. So we could say here that we have normal distribution percentages. Okay, and these percentages, you don't have to have them memorized, but keep in mind that we do have these percentages. They're going to be playing a role in our next assignment. So just keep in mind that those percentages are important because they're true of every single normal distribution that you ever meet. That's one of the ways you can tell if something's normal, is if it follows those percentages. As opposed to here on our non-example, our mean, median, and mode all appear in different places. We have our mean, our median, and our mode. And notice we also have this double camel hump shape, which remember we call bimodal. So once we do that, or once we know that, here on question 9, we want to know what examples or what we know to be the features of a normal distribution. Well, we know, for example, that it's symmetric. Remember we said it has to have that bell curve shape. Remember we said the mean, median, and mode are all in the middle. And I'm going to add that it follows our normal distribution percentages. We'll say follows normal distribution percentages. And I'm just going to kind of flip back to see if there's anything that we may have missed. Bell curve, symmetric. I think that we've probably got it all. So go ahead and make sure you have all of that written down, and then in my next video I'm going to start in talking about problem 10.